All right, so as we finish up chapter 6.5, in this lesson, we're not going to be looking at necessarily the conversions with straightforward measurements or weights or capacity. We're going to be talking about something we talked about in science a couple months back when we talked about distance and how if I knew the rate, the speed that something was traveling in, and how much time it took to get there, I could find the overall distance that it traveled. It also is going to be connecting us back to the original thoughts that we started with this year when it came to basic multiplication, division, addition, subtraction. We talked about fact families, and that fact families isn't necessarily a Go Math adoption wording. However, it was something you guys did for your first 4 years in math in school dealing with Saxon math. It's the idea that if I have three numbers that we know are related as a fact family, that I can have two multiplication and two division problems from those three numbers. If A times B is equal to C, then I can switch those two, and B times A also has to be equal to C. So that would be saying that 2 times 3 equals 6, and I switch those first two, 3 times 2 is equal to 6. Then my other two is taking the answer, the 6, and dividing it by one of those other numbers. So if C divided by A, the answer C, is divided by one of these, it has to be equal to the other one. And then I can switch the A and B again. The C divided by B is equal to A. That would be saying 6 divided by 2 is equal to 3. In the same way that if I switch the 2 and the 3, the 6 divided by 3 is equal to 2. So our fact families allow us to move our things around and still get to the right or the same answer either way. So when I look at these are using all the three letters. I had D is equal to R times T. It could be D is equal to T times R, either way. So my distance, which is D, is equal to my rate, how fast something is traveling, times my time, however long it takes. But if I don't want to find distance and I want to find my rate, then I would just take my distance and divide it by the other one. If I had C divided by A, that would give me my B. Well, R, my rate, how fast it's going, is found by knowing my distance and dividing it by my time. Or my time is found by knowing my distance and dividing it by my rate. So when I do these, I'm going to look at them and say, okay, what information am I looking for? And I have to make sure that I have my other two pieces of information. And that will allow me to pick which one of these that I would use. So if I have these written on my paper somewhere on the pages as I'm working through them, it makes it easier because once I know what I'm looking for, it's either I'm looking for my distance or I'm looking for my rate, how fast it's going, or I'm looking for the amount of time it's going to take. Then these tell me how to do the math. Caution, as I see many years, is when we do the rate and we do the time, people have a tendency to flip the other two pieces of information. The distance has to be listed first, has to go inside the division box, has to be the top of my fraction if I'm going to set it up as a fraction, divided by either the time or the rate. So let's look at what we have here for our first scenario. Helena drives 220 miles to visit Niagara Falls. She drives at an average speed of 55 miles per hour. How long does the trip take? Use the graphic organizer to help you solve the problem. So we're going to have our thinking pattern. We're going to spell it out so we can follow through and understand what we're needing to do in all of these problems. The first thing I need to do is to know the information that I'm given. So in my flow chart here, in my thinking pattern, what do I need to find? So I have to go back to my question, what am I being asked? Well, I need to find the amount of time. How long does the trip take? We use the word time because that's one of the letters in the formula that we're going to use. What information do I need to use then? Well, these are the two pieces of numerical information that I'm given. So I need to use my distance. I know how far she went 220 miles. And I need to know my rate, which is my 55 miles per hour. So I need to use distance and rate. How will I use that information then? Well, first, I'm going to choose the formula. Which one do I choose? I have to choose the one that starts with the T because I'm looking for my time. T is equal to, always the D first, D divided by R. So I'm going to take time is equal to distance divided by the rate at which I'm traveling. So I know I'm going to divide in order to do my math. And then we go up here, and this is my work area. So first, we write the formula that we're going to use. If I have them written on my paper, then I can look and be able to follow along. They're on this page, but just telling you as we get further into it and you do your assignment, if you have them written down somewhere, you can constantly look at it. It makes it easier. Then I'm going to start substituting once I have that formula written in. And substituting means I take the number that I know that value is, and I just plug it in for the letter. Okay? That's your basic way of doing an algebra problem. So I'm going to take my time is equal to, what's my distance? 220 miles. What is my rate? 55 miles per hour. And I'm going to divide. Now the 220 would be over 1, and then I have fractions, and we got to go all the way back to dividing fractions. You know, we had those questions. Can I add fractions? Can I subtract fractions? Can I multiply fractions? All of those are yeses. But can I divide fractions? No, I can't divide fractions. So I have to remember those 3 steps. Keep my first one. Division is going to become multiplication, and then I have to flip my second fraction. I have to find the reciprocal. So I have to set up my math problem then. Remember, if we draw that little pigtail, it reminds us that we're flipping and find the reciprocal of the second fraction, always the second fraction. So I know that my time is equal to my 220 miles, and I put it over 1. This is where it looks like the conversions that we've done for the past 5 lessons now. I know that my rate has to be flipped. So I have 1 hour and 55 minutes. And now I have multiplication. I'm going to get rid of my miles, cross-reduce those labels, and then I'm left with 220 over 55. Well, if I cross-reduce those, 55 goes into 55 one time, 55 goes into 220 4 even times. Or if I multiply across, I would have 220 over 55, which is division, and that top number goes inside the division box, and I divide it by my denominator. Always the setup. So I know that the trip takes 4 hours for Helena to get to Niagara Falls. All right, going through this one. Notice we have all 3 of our choices here. Santiago's class traveled to the Museum of Natural Science for a field trip. To reach the destination, the bus traveled at a rate of 65 miles per hour for 2 hours. What distance did Santiago's class travel? So what distance tells me which one of these 3 formulas I'm going to use. I'm going to use the one where the distance is out in front. So if I know that I have a rate of 65 miles per hour, I have a time of 2 hours, I can then plug them into this formula, and I'm good to go to find my distance. So I would use this one to fill it in, and then I'm going to fill in my information of my thinking chart and my work chart. So what do I need to find? Well, I need to find the distance that they traveled. What information do I need to use? Well, the other 2 pieces of information that I have is I'm going to use my rate of 65 miles per hour, and I'm going to use my time of 2 hours. And how will I use that formula or that information? Well, I'm going to use the formula of distance is equal to rate times time. Once I know what it is, and I know I'm going to plug the numbers in that they give me into the math problem, then it should make the math work pretty easy. So if I have my distance is equal to rate times time, and I plug in, substitute my numbers in, my rate is 65, my time is 2, then I take 65 times 2, and that's my math problem. 65 times 2 is 130. 130 what? Have to have my label on these. If I don't have a label, I'm going to miss a point. Have to be clear on what we're talking about. If I put 130, it could be carrots, it could be people, it could be dogs. I don't know what it is unless you tell me with your label. This one, your label's already given. So 130 miles would be your final answer. They ask you a question then right below that area. Well, what if? So let's think about what if, and we're going to be able to prove. What if the bus traveled at a rate of 55 miles per hour for 2.5 hours? How would that distance be affected? Well, would it be the same since I'm going a little slower, but I'm going a little longer? Would my distance change? Well, let's find out. If I know I'm looking for my distance, it's still going to be distance is equal to rate times time. And I'm going to use my 55 times my 2.5. So I use the same formula, but with different numbers, and I just multiply 55 times 2.5. Handy dandy calculator. Plug it in. You're going to find out that that's 137.5 miles. So the distance is going to increase by 7.5 miles. Maybe there was a detour. Maybe they stopped off for a potty break. They needed a drink or something, and they added a little extra amount of time or a little extra distance. All right, so each one, I'm going to have this up here so we can look at it every time. If you have this written on your paper, every time you can refer back to it so you know which one you're going to use. Mariana runs at a rate of 180 meters per minute. How far does she run in 5 minutes? How far does she run? So I am once again going to be looking for a distance measurement. So I know I'm going to use this first one. Which formula? D is equal to R times T. Substitute my values in. For the R, my rate, and the T, my time. I know I'm going to have distance is equal to then 180 miles per minute times 5 minutes. Or excuse me, meters per minute. So Mariana runs what? Well, then I have to do my math. Handy dandy calculator. 180 times 5 tells me that I have 900 meters. 900 meters in the 5 minutes that we're talking. All right, what about number 2? What if, changing it, Mariana runs for 20 minutes at the same speed? Notice the label change. How many kilometers will she run? So they're going to try to trick you, and we have to make sure we're really reading and thinking about what it's asking. This answer was in meters. This information is in meters, but I have to do my conversion once I get my numerical number for meters into kilometers. So I start with my information that I've given once again, still 180 meters per minute, still now going to be 20 minutes. So 180 times 20 gives me 3,600, but I have to change it. If I think about how I change it with the metric system, once again, King Hector doesn't usually drink chocolate milk. Still this paper, the king is up above. King Hector doesn't usually, that's my meters. So I know I'm going from meters to the king. So I'd have to go up 1, up 2, up to the 3rd. So I'm going left up my stairwell 3 steps. So I'm going to move it 1, 2, 3 times. With it being kilometers, I can't leave it alone. So I have to go up to my deca, up to my hecto, up to my king. That's going to leave me with a decimal number with a different label. So I'm going to have 3.6 km, kilometers or kilometers. All right, number 3. A car traveled, so we're getting away from this runner here, 130 miles in 2 hours. How fast did the car travel? So fast is which of those 3 words up above? Hopefully the word rate popped into your head. So I'm going to use this formula up here because I'm looking at how fast I'm going. How do I do it? Well, I have to know my distance, which I have, divided by my time, which I also have. So if I take my 130, I substitute it in for my distance, and I'm going to divide it by my time, which is 2 hours. Then I can simply divide and get 130 divided by 2. They're both even, so the 2 will go into both of them. 65 miles per hour. Now, you can either write m/hour like I have here, or you can write p mph, which is miles per hour, or you can write the whole thing out. miles space per space hour. Number 4, the subway car travels at a rate, so I know my rate, of 32 feet per second. How far does it travel in 16 seconds? So how far is what I'm looking for. So I'm looking for my distance. My distance is found by multiplying rate times time. I plug in or I substitute the numbers in that I have. So I know if I'm using distance is equal to rate times time, that my rate that they give me is 32 times my time is 16 seconds. So when I multiply 32 and 16, I get 512 feet. That tells me my overall distance that I would be traveling. Number 5, a garden snail travels at a rate of 2.6 feet per minute. At this rate, how long will it take for the snail to travel 65 feet? Well, I'm looking for how long, so I'm looking for my time. Which one am I going to use? Well, up above, hopefully, you know you're going to use that one because I have the t there. I know I have to take my distance and then do the division to that. If I try to do it backwards, my answer is going to be completely wrong. So my distance is 2.6 feet per minute, and I'm dividing by 65. So I set it up. I have 65 feet per minute. I'm going to take my 65, and I'm going to divide it by my rate, which is 2.6. Now, some of us aren't going to remember necessarily dividing by decimals, but we're going to start reviewing here next week after we get through our test in tomorrow's class. I can't divide by decimals. Okay? If the decimal is inside my division box, I'm good. I raise it up and I'm good to go. However, if it's on the outside, I have to remember my OOU. Over on the outside, over on the inside, and then raising it up. When I have 65 divided by 2.6, I have to move it on the outside. That's over. I have to move it on the inside. There's nothing there, so I insert a 0, and then I can raise it up. If there's more decimals behind it, then I would keep my decimal, and if it just ends up being a whole number, I drop my decimal. Well, if I divide 650, that gets entered first into my calculator. Divided by 26, I see that it's just simply 26. So I know I have just a straightforward answer. 26 what? Well, I'm being asked how long, so I know that my label is going to be in my minutes. All right, so squirrel, number 6. A squirrel can run at a maximum speed of 12 miles per hour. At this rate, how many seconds, that's what I'm looking for, think about which one you're going to use, will it take the squirrel to run 3 miles? So when I look at my 3 options of what I'm going to use, which one? The time question again. Am I given my distance? I am 3 miles. Am I given my rate? I am 12 miles per hour. So I'm going to plug in my information. Now, notice this weird, crazy formula that I have put here, or this math problem that I put here. 1 hour times 60 minutes times 60 seconds equals 3,600. Why in the world do I have that up there? Well, when I read it and I see that my rate, or my rate is miles per hour, but the question has to have an answer of seconds, then I have to do some converting. I have to change. So if I know that for every 1 hour, how many minutes do I have? Well, 1 times 60 is just going to give me 60 minutes. Okay? However, it's still in seconds. So every hour, or every minute is how many seconds? Well, that's 60 as well. 60 seconds makes 1 minute. 60 minutes makes 1 hour. So I have to multiply those together to find out how many seconds there are for every 1 hour, so we can do this math problem. For every 1 hour, 60 minutes, and 60 seconds per minute gives me 3,600 seconds, and that's the label that we're looking for. So once I know that, then I can plug in my information. If I know that they run at 3 miles, or run for 3 miles, and my rate is 12 miles for 3,600, should be minutes there, I apologize, then I know I cannot divide my fractions. So I have to keep my first one. Division has to become multiplication. Then I have to find the reciprocal. I have to flip my second fraction. So I know this is actually a multiplication problem once I get it set up. So I should have 3 miles times 3,600, once again that should be minutes, over 12 miles. That's where my conversion allows me to get rid of the mile label. I end up being able to reduce because 3 will go into 3 one time, and 3 will go into 12 how many times? Well, 4 times. So now all I have is 3,600 divided by 4. Or you could multiply straight across 3 times 3,600. And then my denominators would be 1 times 12. And then I would take that product divided by the 12. Once I get rid of my labels and I get rid of my numbers and I'm left with 3,600 divided by 4, then that's just a 900 answer. 900 what though? So remember, we went from hours and we changed it over into seconds. So I have to have a label of seconds. Number 7, a cyclist rides 8 miles in 32 minutes. What is the speed? So I'm looking for my rate of the cyclist in miles per hour. So if I know that I'm going for 32 minutes, now there's a couple different ways that we could set this up. One is not going to make any sense, and the other one will only make sense. So when I know I'm looking for my rate, and I know I have my distance divided by my time, but they want it in miles per hour, then I have to think about what I'm doing with my minutes and my hours. Now, when I set that up as minutes per hour, and I have 32 over 60, the logical thing is often that I'm either going to divide. Well, if I divide that, my numerator by my denominator, I end up with 0.533333 and goes on forever. And mathematically, that's not going to lead me to an answer that makes any sense. So all I'm going to do is I'm just going to leave it as that fraction and then do the math and then see if my answer is logical. So if I know that I have my 8 miles and I'm going to divide, once again, I can't divide fractions. So I'm going to put my 8 over 1. I'm going to find my reciprocal. I'm going to flip my second fraction. And I have my 8 times 60 over 32. Well, when I look at that, I can cross-reduce my labels, but I can also cross-reduce my numbers. 8 goes into 8 one time, and 8 goes into 32 4 times. When I have 60 divided by 4, then, that gives me an answer that is logical. Looks like the corner of my computer is blocking it. So 60 divided by 4 is just 15. That gives me a more logical answer than trying to use 0.5333 repeating forever and ever. So I know that I have 15 what? It asks for a label of miles per hour. But I have to remember that it starts out as minutes. So that's why I have to use this fraction, that there are 32 minutes that we're talking about out of a total of 60 minutes, because the total is going to be for 1 hour. All right, so we're going to jump down to 10. So we don't always do all of these on this other page, but there are 2 of them that we are going to look at. So number 10, once again, my 3 formulas that I could use. What my distance is equal to, what my rate is equal to, what my time is equal to. Andre and Yasmin leave at the same time and travel 75 miles to a fair. Andre drives 11 miles in 12 minutes. Yasmin drives 26 miles in 24 minutes. If they continue at the same rates, their individual rates, who will arrive at the fair first and explain? So what we're doing is we're trying to find out who is traveling at the fastest rate. So when I know who's traveling at the fastest rate, then I can use my information. Here I have 75 miles as my distance for both of them. But I have this one traveling at 11 miles for 12 minutes, and this one's traveling at 26 miles for 24 minutes. So now we have to solve for my time as to who's going to get there quicker. So if I'm going at 11 for 12 or 26 for 24, and I use my information of solving for time, then I know that I could divide 11 by my 12. All right, well, if I'm taking my 11 by my 12, I didn't explain where that came from, and I apologize. We're looking for our time. So we're going to take, I'm going to talk about my rate. I got to see who's going there quicker. So I'm going to take my distance divided by my time. There we go. So 11 divided by 12 gives me 0.916666. I'm just going to round it to my second decimal position on this one, just so I can see where it rounds to. But 0.9, I could scientifically, if I was doing scientific notation, just round it to 0.9 instead of 0.92. You'll get the same idea when we get to the other answer. But when I look at the second one, I automatically notice that my numerator is larger than my denominator. When my numerator is smaller than my denominator, I always get a decimal answer. But when I have a numerator that's larger than my denominator, I get a whole number with a decimal. So I know automatically who is traveling faster. But if I have to prove it, then I have to show my work. My 26 divided by 24 tells me that they are traveling at 1.08. Okay? So if I have a 92 and a 1.08, that tells me that Yasmin is traveling faster. So who's going to get there quicker? Well, Yasmin's going to get there quicker because she travels faster. Okay? So we skipped 7, 8, 9, or maybe just 8 and 9. But on 8, on this question, I want you to do this one on your own. See if you're understanding, processing what we're talking about with these 3 different ones. I want to leave them here so you can look at them, but I want you to go up to this problem and work it out. Pause the video, unpause, check your work, make sure we're on the right track on what we're doing. Hopefully you've done what I've asked. You have an answer up here. Let's look at what it's asking. A pilot flies 441 kilometers or kilometers in 31.5 minutes. What is the speed or the rate of the airplane? So I know from these options, I've put them up here, which one I'm going to use, because I'm looking for my speed, and my speed is always what we call the rate. I know I'm going to take my distance divided by my time. So I've taken 441 divided by 31.5, and I will get my overall rate. So if I have a denominator or a decimal on the outside, I have to move on the inside. So I move it over. There's not one on the inside, so I add it at the end of the number and I move it over 1, and then I raise it up. When I type it into my handy dandy calculator, I take 4,410 divided by 315. That shows me that it's just 14. Then I have to remember what I'm looking for. I'm looking for my rate. My rate is always something per something. In this one, I have kilometers per minute, because those are the 2 labels that we're given. So you should have ended up with 14 kilometers per minute. So I don't think this is a difficult lesson. For a lot of you, I think this lesson is going to be easier than 1, 2, and 3 of chapter 6, because you can think, and we've gotten used to these in-depth thinking questions throughout the year. But if you do have questions, then I've left a couple that we can work together, and you can come and ask. If not, then you have a shorter lesson than we have had all of this chapter. You only have 2 through 5. They are story problems, so you have to think about it and show me the setup so you get all your credit. So I need work, I need answer, and I need label. Each one's worth 3 points. And then on the back, you have your 6 questions. Your first 2 are going to be a review of this lesson, and then 3 through 6 are going to be spiral review from things that we have done before. If you have any questions, come and ask. If not, get your assignment done so you don't have to worry about homework tonight. You should have almost an hour left in class.